So, yeah, good morning. It's nice to see all you again. And I apologize for imposing some technical things on you on a Saturday morning, but I thought I should provide some slides to help you go with it. And so I've given a number of seminars over the years to sort of explore, as much for my purposes as for yours really, of different aspects of the mainly elementary and middle school curriculum. And there's been a lot of teachers who were involved with algebra, but we have never directly addressed algebra. So I thought maybe now the time has come, and I'd like to propose a topic, a seminar that focuses on algebra, but more particularly on the transition from arithmetic to algebra. And it would involve all these subsidiary, does this do the, well, all these, oops, wait a minute. Okay, I'm in trouble. Okay, there we are. Yeah, this is going. Okay. So it would involve all these subsidiary topics. So there were the two really major aspects of it would be variables and word problems, but also fractions and the rules of arithmetic. And also I realized yesterday, and from comments of Aaron Manjaya, that I should have put proportional relationships up here also. So there would be quite a few subsidiary topics that could be of interest to people in lower grades. But let me talk about variables. So we think of algebra as coming to us from the Arabs, but in fact variables were not part of Arabic algebra. They solved their problems verbally. Variables were really an invention of the Renaissance. There was a French mathematician named François Viette, sometimes called Vieta in the Latin form, and he was, it was at the end of the 16th century, he really introduced the idea of variables. And this, one can argue that this was a key ingredient in supporting the scientific revolution that happened in the next century with Newton and Descartes and all those people. So variables are a modern aspect of algebra, but today we think of, in some sense, algebra now, the essential aspect of algebra is learning to cope with variables. So I want to focus on this issue. And variables typically are introduced in a kind of a hodgepodge of different contexts, different issues. They're usually met as first as unknowns in equations, but then they get used for defining expressions or functions and for formulating identities. Identities like the commutative rule of arithmetic and things like that. And then they're used to create more complicated expressions. There's a kind of variable called a dummy variable that you use to indicate how, you know, if you want to make a very big sum of things, you use a variable to label the various parts of it, so you don't have to write out the whole expression. And then, paradoxically, variables are also sometimes referred to as constants. So if you have an equation like 2x plus 1 equals 5, the 2 and the 1 and the 5 are constants. But then once you have this concept of variables, you can imagine that those are some other general quantities, and then you can try to figure out how you would find x for any values of those constants. And this is really the difference between the old Arabic idea of algebra and our modern one, is that we turn the constants into variables also. In the old Arabic algebra, they would, for any given values of the constants, like 2x plus 1, they would tell you exactly what to do to solve the equation. but then we can, if we use constants as variables, then we can write formulas for them. So people have known how to solve quadratic equations going back to ancient Babylonia, about 4,000 years. But the quadratic formula per se didn't really exist until the 17th century. This will be a central topic of the seminar, to study all these different types of variables and to understand that in fact there is a uniform point of view, that you can view all these uses of variables as basically coming from one kind of role. So the variable is being a placeholder for a number. And sometimes, very often, it's important to specify some side conditions on the number, or what is the context in which you're thinking about these numbers. So there's a uniform way of looking at variables, and then there's various contexts and various side conditions that affect the way you think about them in those situations. So I'm hoping that this can provide sort of a better pedagogical approach to teaching variables, and maybe be a little bit less confusing to students. So that's the first main topic. And then the second topic is word problems. And this has been a favorite topic of mine over the years. And one thing I really like about the Common Core curriculum is it's introduced, it's introduced sort of into the mainstream some work done by math educators over the past couple of decades, and they've classified the very simplest kinds of problems, one-step addition and subtraction problems. They've come up with a pretty good taxonomy for these. There are three main types of these problems. There's add to or change problems, where you have some original quantity and then something gets added to it or subtracted from it, and then you have a final amount. And then there's comparison problems, where you have two different amounts and you say one is bigger or smaller than the other. And then there's part whole, where you just have a big collection made out of two sub-collections of some kind. So there's these three main types, and they're divided into various subtypes, which altogether make 14 types of addition and subtraction problems. And so these are the one-step problems. And then an important thing a very valuable thing for teachers to understand is how to combine these one-step types into more complex types. So you start off with building two-step problems. And so let me just give some examples of this. So here is one of the types: comparison, more, smaller, unknown. So an example of a problem of that type would be, there's 16 boys in Mrs. Holloway's class. There are 8 more boys than girls. How many girls are in Miss Holloway's class? So you would just solve this by saying, okay, I've got 16 boys. There's 8 more boys, so I subtract 8, and then there would be 8 girls. So this is a pretty straightforward problem. And then another type of one-step problem is the part whole, where a part is unknown. So here we would say there are 24 students in Mrs. Holloway's class. 16 of the students are boys. How many of Mrs. Holloway's students are girls? Okay, so there are 24 students in all, 16 are boys. You take them away, you'd be left with 8 girls. So these are 2 one-step problems, and then you'd like to try to combine those into a 2-step problem. And we've done this in my seminar, and this is the kind of problem that often results. Here's a 2-step problem. So there are 24 students in Mrs. Holloway's class, and there are 8 more boys than girls. How many girls are in Mrs. Holloway's class? And this looks like this feels like a combination of the 2 one-step problems that I just showed you, but we haven't told you either how many boys there are or how many girls there are. So this is, in some senses, not strictly a combination of those. You can't solve one of those problems in sequence and then solve the second one. You have to do something with both of the numbers together. Very often, this kind of problem in the United States is approached with algebra. And in fact, I was just down in Texas, and we gave this problem to a class of prospective teachers, and it was actually a lot of them couldn't solve it, but some of them could, and they used algebra. They solved it more or less like this. So if you approach it with algebra, you would say, well, let G be the number of girls in Mrs. Holloway's class. Then the number of boys in Mrs. Holloway's class is G plus 8 more. So in all, there are G plus 8, which is 2G plus 8 students. And since there are 24 students in all, you conclude that 2G plus 8 is 24. And then you solve this by the techniques that you learn in algebra. First, you subtract 8 from both sides to conclude that 2G is 16. And then you divide by 2 to conclude that G is 8. Okay, so this would be the algebraic approach. But if you think about that carefully, you may be able to come up with an approach that doesn't involve actually introducing the variables. So you just think about the structure of the problem, and you say something like, well, since there are 8 more boys than girls, let's get rid of 8 of the boys. Let's send them out to play for a while, and then we have the same number of boys and girls in the class. And since we've gotten rid of 8 boys and girls, we know we have 16 left, and half of them are girls, so that would be 16 over 2 or 8. And so, okay, so one of these solutions involved algebra and introducing variables. The other one was just sort of thinking with the quantity, with the information you were given, and thinking how to get the answer. But if you look at the calculations that are done, the calculations are exactly the same in both solutions. First, you subtract 8 to get 16, and then you divide by 2. There was exactly the same sequence of calculations in both. So the point here is that there is a very porous borderland, or a very wide and ambiguous borderland between arithmetic and algebra. And I think many students just get the idea that algebra and arithmetic are just, whoa, totally divorced subjects. But we want to explore, the second main topic theme of the seminars, we'd like to explore these word problems that you can approach from both directions and sort of understand what they're about and how you could maybe use them to move students from arithmetic to algebra. So those would be the 2 main topics of the seminar, and then we would also spend some time worrying about fractions, which are also, there are many aspects of fractions which are essentially, they embed themselves in abstract algebra in a very natural way, and the rules of arithmetic are also more recent algebra that are sort of, they get put in the curriculum, but in a very uncomfortable way. Nobody really understands, I think, exactly what role the rules of arithmetic should play in the curriculum. So we'll think about that issue a little bit, and then also how the theory of ratio and proportion is kind of a halfway between arithmetic and algebra. So those would be the themes of the seminar. Thank you.